You're listening to the Phil Klein Dental Podcast from VivaLearning.com. In the past, we didn't have many choices when it came to CAD CAM blocks, but today we do. So in this episode, we'll be talking to a dentist who is well aware that zirconia wins the strength battle, but he has plenty of reasons to stay the course with lithium disilicate. He specifically prefers a lithium disilicate block that saves him the step of firing after chairside milling. To tell us all about it is Dr. Yao-Lin Tang, who has over 20 years of practical knowledge in cosmetic and general dentistry. He is a CEREC user since 2005, a certified CEREC trainer, and a visiting faculty at cdocs.com. Dr. Tang, it's a pleasure to have you on the show.
Hi, Phil. Thanks for having me here.
Yeah, we're really happy to have you. And, there's a big question in dentists' mind between using some of these materials these days, especially when it comes to CAD CAM blocks. And I know you're a big fan, just talking to you offline, you're a big fan of lithium disilicate. So we'll get into that later on in the program. But first, I want to begin with a simple question. Why did you decide to become a CAD CAM dentist 18 years ago?
I think back to 2005. Before that, of course, I'm like most of the other dentists that we take an impression, PVS impressions, and we send the impression to the lab and have lab to do all our crowns. And we have been suffering from, like remake, the contact that is not good. The temporary crown came off, especially on a long weekend. They call you for emergency. So I was invited to the Peterson's sales event, and I discovered the CEREC systems in 2005. And to me, I feel that is the way to go. It's like a win-win situation for both dentists and for patients. First, for us, it made my procedure a lot faster, more simplified. And I have all the control about contact, occlusion, margin. I prep my own teeth. I mark my own margins. So that will make a lot more sense than sending it to the lab. And I don't have to do temporary, so I don't have to worry about if my temporary is going to come off over a long weekend.
Right.
So that's why I decided to jump into this trend.
Right. So you're visiting faculty at CDOCS. That's in Scottsdale, Arizona, right?
Yes.
Yeah, I've been there. It's a very nice training facility in a beautiful Scottsdale. Yep, I was there. And we actually did a live podcast from there at the Spear Center several years ago. So you're into CAD CAM dentistry, but some dentists are using digital dentistry, but they're just scanning and then they send the file to the lab. But it's important to you, obviously, to get it in one day, right? Because you obviate the need, as you explained. You don't need a temporary for the patient because they get their final prosthesis the same day. Tell us about the blocks that you're using. What are the most common blocks that you like and why?
When I first started my, my CAD CAM dentistry in 2005, at that time, we only have 4 or 5 blocks available, and so it's pretty easy for us back then to choose a block because basically you only have 3 or 4 to choose from. But today, there's so many different type of block. There's a ceramic block, there's a lithium disilicate block, there's a resin block, there's a zirconia block. And I understand that most of the doctors will go for a stronger block, which is zirconia. Zirconia, not only in today's CAD CAM dentistry, even for most of dentists, zirconia probably is the most used material in dentistry right now. But for me, I'm more like biomimetic dentistry type. So I prefer to choose something that is similar to what Mother Nature give it to us, like enamel and dentine, instead of choosing the strongest material, which is like 1,000 megapascal zirconia.
So Dr. Tang, you mentioned biomimetic as an important factor. You're willing to obviate the strength of a material like zirconia for a different kind of material that's more conducive to the physical attributes and characteristics of natural tooth structure. So tell us about that.
Yes. To me, I think the definition of biomimetic dentistry is, we should respect Mother Nature's creations. So we were respecting and emulating the nature with the material that we have. For us, the teeth consists of the dentine, the enamel, and the DEJ. So my goal is to try to mimic that dentine, enamel, and DEJ, which is called by Dr. Pascal Manet. I'm a big fan of him. So he called that dental trinity. So my goal is to try to repeat that dental trinity. So for me, dentine, I think the composite is more similar to dentine. And the enamel, lithium disilicate is very, very, by all the physical property is closest to the enamel, which is lithium disilicate. And the DEJ, we will use the composite cement to replace that DEJ, cement will be using that composite cement to replace that DEJ. So talking about lithium disilicate. So the reason why I like lithium disilicate is because lithium disilicate has very much the similar elastic modulus and also has similar the biaxial flexural strengths like enamel. Our enamel have about 80 elastic modulus and lithium disilicate about 95, and enamel is about 200 megapascal strengths, and lithium disilicate is about 300 to 500 megapascal strengths. So that's why I prefer to use lithium disilicate when I can for my CAD CAM dentistry.
When you talk about modulus of elasticity, you're talking about the firmness or flexibility of the material.
Flexibility, yes.
Yeah, the flexibility. The higher the modulus, the more flexible. The lower the modulus, I think, the stiffer, if I'm correct on that. So lithium disilicate, you're saying, matches those physical characteristics of natural tooth structure better than some of the other materials, such as, I guess you're talking about zirconia, for example.
Mm-hmm.
And even the composite blocks, the resin block.
Composite is the best to replace the dentine because it's closer. All the physical, the property is similar to the dentine.
Now, what about those cases where you need strength? You have a patient that has an occlusal system where they're a bruxer. It's important to have a material that's super strong. Does that override the notion that maybe the physical characteristics maybe are not as naturally representative of the tooth structure, but the strength is more important?
Yes, I mean, I'm not saying that I will never use zirconia. I do use zirconia, but not as often as most of the dentists. So the case that I use zirconia is, first, when I don't have enough minimum thickness, enough clearance for my lithium disilicate, then I will go for zirconia. And when I need to do a bridge, then I will go for zirconia. Because again, in order to use a lithium disilicate as a bridge, you must have enough, the strength of between the connectors, and the zirconia will be a lot easier to get the strength of the connector size. So I'm still using zirconia, but I just don't use it as often as most of the dentists. And for me, again, as long as I can get that minimum thickness, which is about a millimeter thickness for lithium disilicate, I've been doing this for long time, since 2005, and ever since the EMAX, the first lithium disilicate block available is EMAX. As long as you bond your lithium disilicate in, which is very, very important, that you have to know how you treat your lithium disilicate for bonding. Then as long as you can have that minimum thickness there, I think strength is not an issue.
So you mentioned EMAX. What kind of blocks are you using in your office?
Right now, if I do need that strength, I use lithium disilicate, which is nowadays I using the LiSi block from GC. If I'm doing an inlay or onlay, I don't care much about that strength. I use hybrid block, which is a composite block. But, again, for the full coverage crown, normally I will go with the GC LiSi block.
Yeah, so that's LiSi, L-I-S-I from GC America. Why are you using that block in particular? Is there any particular reason that you like that particular material?
Yes, GC LiSi block, it's a lithium disilicate block, of course, and the original, the first CAD CAM block for the lithium disilicate, which is EMAX. But EMAX has all the good history and all the good benefit of using EMAX. But EMAX also has some disadvantage. we all know that the Emax margin integrity is not as good. Once we mill that the crown out, it's easy. Sometimes you will see those are chippy margins because again, it's just because of the physical property of the Emax. So the marginal integrity is not as good. And also that lithium Emax block, it's in purple stage because it's not fully crystallized. So after you mill it, it's in purple stage. You have to go into oven, go through a 14 minutes oven cycle in order to make it crystallize, to be getting that tooth color shade, and also to get that 350, or now they call it a 500 megapascal strength. And LiSi actually is a lithium disilicate. The GC-LiSi block is a lithium disilicate block also, but because it's GC's technology, so it's a fully crystallized block. So the workflow is super simple. You just need to mill it, you polish it, and it's ready to be delivered. And because it's fully crystallized, so the margin is, you can make it super thin, and the margin is very, very smooth.
And the strength of the LiSi block is the same strength you're getting with the typical Emax, the ones that you actually have to put in the oven for 14 minutes?
Based on the GC, their informations, it's 400 megapascal. And Emax, right now, they claim that they have 500 megapascal strength. But when they first announced the Emax back to more than 10 years ago, they say the strength of the Emax is 300 something megapascal. So I think the composition, everything should be the same, but somehow they change it to 500. I don't have any testing, facility in my small office, so I don't know. But I think they should be pretty much equal about the strength.
So you're getting basically the same benefits of lithium disilicate in a block that you're milling chairside without 14 minutes of firing it up, right? You're going right to polish.
That is correct. And also don't forget, when you put into the oven 14 minutes, when they finish the crystallization cycle, that crown is still super hot, so you cannot touch it. You have to wait until it cools down to touch it. So it's not just a 14 minutes though.
So in your experience using lithium disilicate blocks, specifically the LiSi block from GC, and you've been doing this for many years now, have you seen failures, fractures, debonding? What are you looking at as far as the failures compared to what you used to do with Emax or other types of blocks?
Yes, of course, I have to be honest with you. Definitely, I have some failure case. Yes, but is it more than Emax? Is it really, really bad? Not at all. To me, I feel like as long as I get, again, I've been using quite a lot of different material, but as long as you get that minimum thickness, 1 millimeter, and you treat your ceramic right, you actually bond it in, you treat your prep right, then to me, the GC-LiSi is similar to Emax.
Right.
The success rate.
It's just more convenient for you.
So a lot more convenient, yes.
Yeah. So tell us what the critical steps are to make the lithium disilicate in your office where you get the high success that you do.
Yeah, of course. The GC-LiSi block, or for all the lithium disilicate, you have to me, I bond my lithium disilicate in all the time, 99% of the time when I can. And you have to treat your lithium disilicate integral surface right. So once I finish the milling, I take it out from the milling machine. I do a try-in on patient's mouth. The main purpose of doing a try-in intraorally is not to check the occlusion. I trust my occlusion from my CAD CAM systems. So I don't check the occlusion before I actually bond it in. So my purpose is checking the marginal fit. If there's any open margin, how the margin fit. And also I check my proximal content strength. So as long as everything is right, then I actually go ahead and polish it. And if you like, another benefit of using LiSi is if you really like, you can actually glaze it. So that will take about 11 minutes, depending on the system, the glaze system that you use. So you can glaze it if you want to, but nowadays, normally I just, highly polish it, and it takes me about 3 to 5 minutes, normally about 3 minutes to polish it. And then this is the most critical step of the whole thing is to how you treat your lithium disilicate integral surface. So first, you will need to use 5% hydrofluoric acid to etch it for 20 seconds. And once you etch it, you have to fully rinse it with water. And then once you rinse it, you have to make sure your bonding surface is nice and clean. You can either use a steam or use an ultrasonic bath. Personally, I like to use an ultrasonic bath, and I use an ultrasonic bath for about a minute. Use alcohol or with distilled water to clean it. And once you clean it, you take it out, you dry your surface, and then don't forget you have to use a sealant. And for me, I use my the G multi primer as a sealant. Then you are ready to bung in your restorations.
So tell us how you prep the tooth itself.
It all depends. Sometimes I do IDS, sometimes I don't. I don't do IDS all the time. But, for the simple, straightforward case, I will, of course, you put in your isolation, rubber dam, or, the isolite to get the isolations. Then I normally do etchants. Whatever bonding I'm using, I always use etchants. So either I do select etch or I do total etch. It all depends on the tooth. So let's say I was etch the tooth. If I do total etch, I was etch on the enamel first, and then I go on to dentine. So I try to etch my enamel for 30 seconds, and then dentine for about 15 to 20 seconds. Then I completely rinse it off. And for a straight line workflow, I use the GCM1. That's their new cement. So it's a self-adhesive cement, but they also come with a primer called AEP, Adhesive Enhanced Primer. So if I'm using the GCM1 cement, after I etch it, I rinse it dry, I clean it, then I apply the AEP, Adhesive Enhanced Primer. So I use AEP to rub on the surface, the prep surface, for 10 seconds. Then I dry it for 5 seconds. I load the cement. I sit my crown. I take cure it. I clean up the cement. Then I fully cure it. That's how I do it for most of my case.
It seems to be pretty successful because you've had a lot of years to see the outcomes of these cases, which have been very high, as we discussed earlier. So what would you tell, in closing, Dr. Tang, a new dentist who's getting into CAD CAM? Let's say they're sitting at your class at CDOC or wherever you're teaching. What advice would you give them as a young dentist to say, this is something that you really have to keep an eye on to really ensure predictable, really solid outcomes of clinical success using CAD CAM?
I think CAD CAM, my daughter is in dental school right now also, and I know that the school don't teach much about CAD CAM. So when you first out of school, you get into CAD CAM, you had to learn slowly, and it do it slowly. You don't want to just jump everything in, everything CAD CAM, but for CAD CAM, your prep will be different. Like if you're doing a biomimetic dentistry, you don't prep as aggressive. There's a lot of difference right there. But you want to start with, you want to pick the right patient first. The most important is to pick the right patients, right? And pick the right tooth to start with. And then you start from the easy step, like inlay, onlay. Then you move on to the full coverage crown. Then you move on to the multi-unit, quadrants. That's my advice.
Yeah, and what is the big difference in the prep design when using CAD CAM? Is it the fact that you're scanning and you want everything rounded very well, no sharp edges?
Yes, that is correct. I mean, because again for CAD CAM we using a mini machine, which is your restoration. The integral surface is milled by a burr, and all the milling burr has a size of the diameter, right? So it's about a millimeter diameter. So something that the new CAD CAM dentists don't understand is after they prep their teeth, they have patients to bite down and they look at, oh, okay, I got 1 millimeter clearance or I got 1.5 millimeter clearance. But once you scan it, but his prep is all sharp, whole bunch of sharp edges. So once you scan it, you design, and like, wait a minute, why I get that minimum thickness warning? I don't get my 1 millimeter or 1.5 millimeter. Why? So something you have to understand is, again, all the restorations is milled. That's why it's called mini machine. It's milled by a bird, and bird has a thickness. So that if your prep is sharp, then you will get, we call it an over mill by the mini machine. So your prep had to be smooth, had to be rounded. That is the key.
Dr. Tang, I think you covered it very well. I certainly appreciate your time on this podcast, and we'll have you on again, and you'll keep us updated on some of the things you're learning as you teach, because I know when you teach at a facility and you get questions from students, you always learn new things yourself and then incorporate that back into your teaching. So you'll keep us updated on future podcasts. I really would appreciate that.
Thank you. Thank you, Phil.
If you're enjoying this podcast, please leave a review or follow us on your favorite podcast platform. It's a great way to support our program and spread the word to others. Thanks so much for listening. See you in the next episode.